Aloha, welcome to this demonstration of the Kapi'olani Community College simulation. To begin, let's test by clicking here for a HUD. Please keep the HUD, and now you will look for the HUD in your inventory. Double click the bike HUD 4 to vary. To interact with the simulation, begin by clicking on the HUD. The first part of the simulation is to enable students to identify the components of the Monarch cycle and power meter. So following the instructions here, first we have to locate the seat assembly and click on it. And if I click on the incorrect response, it will let me know, and I have the opportunity to try it again. And as I know, this is the answer for it. Next will be to identify the bolt to remove and adjust the seats. So to find this, we'll have to fly to the other side. That is the bolt. Let's click on that. Once we get the correct answer, it will then prompt us to identify the handlebar assembly, which is this portion. Now we have to locate and click on the adjustment lever, which is right above the handlebar. The next thing is to locate the resistance adjustment knob, which is found right here. The last part is to locate the LCD readout panel, which should be right here. Let me adjust the view. There you go. Now once we have completed this section of the exercise, the next section will be to run through a testing procedure. And as you may have noticed now, there is a blue sphere located right above my avatar, and there is a teleporter which will bring us to the inside of the building right behind me where the cycle testing is being done. So let's click on the teleporter now. Now that we're in the room, the next part of the simulation will begin by clicking on the seat. Let me just readjust the view so that we can see the whiteboard as well as the HUD. So the first part is talking about the connection to the heart rate monitor. So answering this question here, if there is no pulse reading, what do you do? I believe the answer here is D. The simulation now gives you the scenario of an adult average healthy male, 47-year-old, and using the relevant tables that can be found in the student's lab manual, they are to decide now on the actual settings. So let's click on the adjustment knob now to begin the exercise, the test. And that's the adjustment knob here. Using the relevant tables in the lab manual, the students will decide, and the optimal power rating to start would be 2.0 here. So let's click on start to begin. As you can see, the avatar has begun the exercise. Let me now zoom in on the whiteboard, which will record the heart rate during the exercise. So this exercise simulation is done in real time and will take a total of 8 minutes to complete. As you can see, the heads-up display will provide the RPM as well as the heart rate at every interval, every 1 minute interval. So we're coming up to 1 minute, and the heart rate is 115. The system will continue to monitor the heart rate, and we will get a second reading at minute 2. We're coming on minute 2. And the heart rate is 121 beats. At the end of minute 3, which marks the end of stage 1 of the testing, the system will prompt the students to make a decision on whether or not they would change the power rating based on the heart rate of the client. We're coming on minute 3. Heart rate is at 124, and based on this reading as well as referring to the lab manual, the students will then decide the new power rating. In this case will be 2.5. We'll continue to monitor the heart rate at minutes 4, 5, and 6. The heart rate at minute 4 is 135. Coming up on minute 4, 5. The heart rate is registering at 138. The next decision point will come at after minute 6. And based on the pressing procedures, if the heart rate between minute 5 and 6 are within 10 beats per minute, then the cool down phase should be initiated, and the decision will be to what power rating should be set. on minute 6. So the reading is 142. So the difference between minute 5 and minute 6 is only 4 beats per minute, and so it's time for the cooldown phase. In this case, the power rating should be brought down to 0.5. The purpose of the cooldown phase is to ensure that the client's heart rate goes below 100 beats per minute, and they will continue moderate for an additional minute, ending at minute 8. So as you can see in the simulation, the RPMs is slowing down now to bring down the heart rate, and at minute 7 the heart rate is 116, so it should go down below 100 beats per minute in minute 8. Coming up on minute 8, which will be the end of the test simulation. And the heart rate is 98. As you can see now, the whiteboard has changed color. For each stage, if I click on the feedback board, it will give the feedback on the results. In this case, stage 1 using 2.2 kilogram resistance was ideal. Similarly, clicking on stage 2 will also provide the feedback information. Let's try that again. Using 2.5 kilogram resistance was ideal. And last but not least, for stage 3, if the student selected the incorrect resistance level, then it would be color-coded red instead of green. In addition, an email was sent to the instructor at the end of this simulation to provide a report of the student's performance. And with that, we end this recording of how the Astron cycle test simulation is done here.